Hello everyone, and welcome to this audio podcast. This audio podcast is part of the Contemplate. This audio podcast is part of the Echo and Update. This audio podcast is part of a Labostix Blizzard. This audio podcast is part of the specials, and this audio podcast is part of a Storm Labostix production. Excuse me. To begin with, a bit of introduction into looking at some works that have been drafted and sort of completed by a student in the sciences and within one of the academic institutions in the United Kingdom, and where the student looked at where the student Bohtha looked at some works in around diagnosis methodologies used or utilized to determine COVID-19. So a bit of intro then. In around 2019, a viral infection, sort of broke out in the Wuhan Province in China, and it was referred to as part of the adenovirus taxonomy, or as part of the adenovirus genera or taxonomy, referred to as specifically in around coronavirus. And a coronavirus, 19, or COVID-19, or SARS-CoV 19, and it was and generally can cause severe acute respiratory syndrome, coronavirus 2, or SARS-CoV 2. And this is this had been basically within the Wuhan province in 2019, the third outbreak by the sort of genre of adenovirus, being the coronaviridae, taxonomy or family after SARS-CoV, which originally broke out in around 2002, and in around and additionally, or also in the Middle East, and also in Middle East, and also had been referred to, or where there had been where had broken out in amongst Middle East in some regard, and had been referred to as Middle East Respiratory Syndrome, or MERS in 2010. After that, laboratory specialists and scientists had sort of had then sort of collated some of the evidence that the next coronavirus outbreak will be caused, or would be caused by bat species within China. COVID-19 was was declared as sort of as an epidemic or pandemic by the World Health Organization, WHO, in on March 2020, and up until up until up until sort of more recent times, the number of deaths have been 1.5 million, sorry, 1,595,100,000 and 187 deaths, which have been reported globally. The recent In this works by M. Bohtha, the investigator, sorry, the student and investigator had looked to describe the clinical features of COVID-19, and the sort of analyses from data, and particularly in around a patient case who suffered from long-term COVID-19. SARS-CoV-2 also contained the largest positive single-strand RNA, or ssRNA, which has 29.8 kilobases genome to produce 26 proteins. The subgenomic RNA, or sgRNA, codes structural proteins, spike proteins, and envelope proteins, membrane proteins, and nucleocapsid proteins. The helical nucleocapsid lies under a bilayer, under a particular bilayer, and the two-domain spike protein gives the coronavirus, a sort of a crown-like shape, but also additionally sort of a spike, sort of like shape. Additionally, the glycoprotein membrane contributes towards assembly, pathogenesis, and exocytosis. RNA polymerases and RNA recombination also lead to mutations, allowing the coronavirus to have the basis of where sort of adenoviruses advance into coronavirus, to have a sort of a high genetic diversity and capability to infect various hosts. Several mutations were found in nucleocapsid, envelope, and spike proteins, and these had led to several strains of SARS-CoV-2. The viral genome sequence of SARS-CoV-2 is in around just under 80% similar to SARS-CoV, and 51%, around just over 50% identical to MERS-CoV, and around just under 90% similar to the BACT SL-CoV, as ZC. H-CoV NL63, H-CoV 229E, and H-CoV 0C43 and HKU1 have caused mild upper respiratory symptoms and severe infection in young people and elderly, in amongst where it has been evidenced in amongst the literature. SARS-CoV-2 at the same time SARS-CoV-2 use angiotensin converting enzyme 2, or ACE2, as the receptor to recognize and bind to spike SARS-CoV-2 SARS-CoV-2 use of and the use of angiotensin converting enzyme 2 or ACE2 as it has been where there's been a link to determine one of the main receptors to recognize and bind and cause a sort of a bind or a link to the spike protein. ACE2 at the same time is present in a respiratory tract, the cardiovascular, and in around the renal, the liver, and brain and skin, alveolar and epithelial type 2 cells, and so forth. So that draws this intro to a close. This intro as part of the Contemplate, this audio podcast as part of the Echo and Update, this audio podcast as part of a Labostix Blizzard and the Specials, and this audio podcast as part of a Storm Labostix production.